This video is part 3 in a series about using simple continued fractions to solve linear Diophantine equations. We'll use the process from part 2 and work an example. Let's get started. In part 2, we showed this process for solving linear Diophantine equations. The equation itself has the form ax plus or minus by equals plus or minus c, where a, b, and c are positive integers and a and b are co-prime. The process has 4 steps. The first 3 steps involve doing things with simple continued fractions, and in step 4, there are 2 sets of expressions for x and y. One set is for the case when we have ax plus by equals plus or minus c, and the other is for when we have ax minus by equals plus or minus c. What we're going to do is solve 101x plus 27y equals 540. A is 101, b is 27, and c is 540. Back in part 1, we showed this graph, which has the solutions within the axis for 101x plus 27y equals plus or minus 540. X is on the horizontal axis and y is on the vertical axis. In this video, we'll find expressions for the black dots, which is for 101x plus 27y equals 540. We're going to work through the 4 steps, but first, stop the video and give it a try yourself. How much of this can you do? Can you find the expressions for x and y? In step 1, we expand a over b equals 101 over 27 into a simple continued fraction. We won't go through this line by line. There's a separate video about expanding numbers into simple continued fractions. But here's a table that shows the work. I encourage you to try to do this yourself. The result is 101 over 27 equals 3, 1, 2, 1, 6. And we'll note that n equals 4. N is the subscript for the last term. It's the value of k in the bottom row. In step 2, we calculate minus 1 raised to the n plus 1 power. It equals minus 1 to the 4 plus 1 equals the 5th power. This equals minus 1, which does not equal the sign of the right-hand side of the equation we're solving. That is positive 1. So we have to convert the simple continued fraction to its longer representation. To convert it, we subtract 1 from the last term, so we take 1 away from 6 and get 5, and we append a 1 at the end. The longer form, therefore, is 3, 1, 2, 1, 5, 1. There's another video about the shorter and longer representations if you're interested in more information. In step 3, we calculate the conversions. We calculate them for the longer representation because we had to convert the continued fraction to the longer representation in step 2. Try to do this yourself. We won't go through calculating the convergence line by line because you can see how to do this in a separate video. But here's a table that shows the work. In step 4, we can write out the expressions for x and y and then calculate as many of the values as we like. Our equation had the form ax plus by, like this, so we'll use these expressions. X equals c, which is 540, times q sub n minus 1, which is 23, minus b times t. b is 27 and t is the set of all integers. When we multiply that out, we get x equals 12,420 minus 27t. And y equals minus c, so minus 540, times p sub n minus 1, which is 86, plus a times t. a is 101, so it's 101 times t. What we get is y equals negative 46,440 plus 101t. These 2 equations can be used to calculate values for x and y, which are integer solutions to this equation. One way to check if we got this right is to calculate some values of x and y in 101x plus 27y. You can make a little table with columns for t, x, y, and 101x plus 27y. In each row, we should get 540 in that last column for 101x plus 27y. I'll leave it to you to do this though. Another way to check our work is to substitute the expressions for x and y back into the original equation. Let's do that. 101x plus 27y equals, and we'll use these equations here, 101 times the quantity 540 times 23 minus 27t, plus 27 times the quantity negative 540 times 86 plus 101t. All good so far? Pause the video and make sure you see how we did this. Notice that in this term, we have 101 times negative 27t, and in this term we have positive 27 times positive 101t, so they cancel out. There's another simplification we can do. In the terms that are left, we have 540 here and negative 540 here, so we can factor out 540. Now we can write 101x plus 27y equals 540 times the quantity 101 times 23 minus 27 times 86. What's in parentheses equals 1, so 101x plus 27y equals 540, confirming our expressions for x and y are correct. As a recap, we use simple continued fractions to solve a linear Diophantine equation. That's all for now.